Presentation videos connected to the other two videos on the first generation real prototype of a Forcefield shield for spaceships, but it uses iron core plates, 3-foot thick iron core plates with a ceramic layer all around filled with a high explosive thermite. The rest of the video explain this. Anybody watching this is under a non-disclosure anti-theft
Okay, now we're
contract.
going engineer design the first generation Forcefield shield using the magnetic grapple arrays. This magnetic grapple arrays are engineered to grab the iron core of a 3-foot thick sheet of metal that is inside a 3-foot thick layer of ceramic all the way around the iron core. The magnetic grapple arrays position each sheet around the spaceship to form the first generation Forcefield shield. Though the ceramic is mixed with high heat resistant reflection mirror pigment to reflect the laser beam back at the attacking ship. This shield is designed to defend against kinetic ballistic projectiles as well as laser beams. Once a sheet is damaged to 10%, it itself can then be propelled at the enemy's ship. The inside of the sheet could be filled with high explosive thermite and use as railgun warhead ballistic projectiles. Then a new shield sheet is positioned in its place with the grapple array as part of the shield. First generation magnetic grapple Forcefield shield system. Engineering design. System overview. The M-Grasp magnetic grapple reactive armor shield platform is a modular, active defense shield system that manipulates composite armor plates via controlled magnetic arrays to provide 360 degrees protection for spacecraft. Core components. 1. Magnetic grapple arrays. Positioning. 32 primary arrays distributed across spacecraft hull. Specifications. High torque electromagnetic manipulators with 6-axis control. Superconducting coils for rapid engagement disengagement. Range, 50 to 100 meters from hull surface. Max lift capacity, 40 metric tons per array. Response time, less than 0.5 seconds for repositioning. 2. Composite shield plates. Dimensions, 4 meters times 4 meters times 1.8 meters total thickness. Layered structure. Layer 1 outer, 0.9 meters ceramic composite. Alumina zirconia matrix with embedded reflective pigment YBO. Diamondoid reinforcement fibers. Surface, active mirroring with electrochromic adjustment. Layer 2 core, 0.9 meters high purity iron laminate. Grain-oriented silicon steel 3% C. Laminated to prevent eddy currents. Contains grapple engagement points. Internal cavities. Thermite-filled compartments AL, FAON and othermite. Shape charge liners for directional detonation. Micro-thruster array for propulsion. Operational modes. Defensive configuration. Kinetic defense. Plates positioned to create overlapping coverage. Angled deflection for railgun projectiles. Redundant layering, minimum 3 plates along any attack vector. Energy weapon defense. Mirrored surfaces reflect 94% of incident laser energy. Rotating plates distribute thermal load. Ablative ceramic dissipates residual heat. Damage management protocol. Backquote. If plate, damage greater than 10% then 1. Designate as expendable. 2. Rotate to rearward position. 3. Load firing solution data. 4. Await launch command. Backquote. Offensive conversion. Railgun munition configuration. Magnetic arrays reorient plate with pointed edge forward. Internal thermite ignited for propulsion augmentation. Terminal guidance via residual magnetic signature. Warhead effects. Kinetic penetration. 3 meters steel equivalent at 0.1 C. Secondary thermite dispersal on impact. Fragmentation from ceramic breakup. Deployment system. Reserve magazine. 50% redundancy in shield plates. Automated reload from internal bays. Plate fabrication via onboard 3D printing emergency. Control systems. Primary, AI-driven threat prediction, 100 ms reaction. Secondary, manual tactical override. Sensors, litter projectile tracking. IR laser detection. Predictive impact modeling. Power requirements. Standby, 15 megawatts array maintenance. Active repositioning, 150 megawatts peak. Launch mode, 450 megawatts 3-second burst. Limitations and countermeasures. Vulnerability windows, 0.8 second gap during plate replacement. Magnetic countermeasures, requires M shielding for ship systems. Close-in defense, secondary point defense needed for debris. Heat sink capacity, 2.4 gigajoules per plate before mirror degradation. Tactical integration. Backquote. Priority defense matrix. 1. Direct energy weapons right pointing arrow reflective surfaces. 2. Hypervelocity kinetics right pointing arrow angled composite laminate. 3. Plasma weapons right pointing arrow sacrificial plate rotation. 4. Expendable plates right pointing arrow offensive counterattack. Backquote. First generation constraints. Maximum coverage, 70% of ship at any moment. Reload time, 12 seconds per replacement plate. Operating range, close quarters within 1,000 kilometers. Plate lifetime, 8 to 12 direct energy weapon strikes. Dash. Design note, this represents a transitional technology between passive armor and true energy shielding. The dual-use nature defensive-offensive significantly increases tactical flexibility but requires sophisticated AI control to manage plate inventory and positioning mathematics in real-time combat conditions. The system's brilliance lies in turning damaged components into weapons, creating a logarithmic cost imposition on attackers while maintaining continuous defense coverage.
That part about it. That part about where it's talking about it. Once it gets to 10%, it's supposed to be once the ceramic gets damaged to where there's only 10% ceramic left, then the sheet is disposed of and used as a ballistic warhead projectile. It's not supposed to be disposed of at just 10% damage. Once the ceramic coating around the iron core gets depleted to where there's only 10% left of the ceramic coating, then it gets deployed as a ballistic warhead kinetic railgun projectile. Anybody watching this, you're under a non-disclosure contract, anti-theft, all that, all the I's dotted and T's crossed. Anybody interested in providing me financial compensation and funding this project, that's my email.